Howdy, my name is Connor White, and today I'll be covering the importance of pH in solutions. Moving to campus this past year has been full of many surprises. However, none have come even close to that of the quality of the tap water here. Many students have expressed discomfort at both its flavor and texture, and I personally have found my skin even becoming more dry after prolonged contact. So, after covering multiple pH units in chemistry, I was determined to get to the bottom of this phenomenon. First, let's discuss what pH is. In simple terms, pH is a measurement that allows us to determine just how acidic or basic a solution is. Typical pH scale goes from 0 to 14, 0 being very acidic while 14 is very basic, and 7 of course is neutral. Now, acidity is determined by the amount of hydrogen ions within a concentration, which can be seen through the formula pH equals negative log of H. Now, by analyzing this, we can see that the greater the hydrogen ion concentration is, the lower the pH gets, and thus the more acidic a solution is. Now for the actual experiment. So I have here two common instruments used to measure pH, the first being the actual test strips, and the second being a pH indicator solution. So the latter option seems to be more accurate in determining the value, however we'll be utilizing both to support our results. At home, I have a water filtration machine that can dispense solutions with specific pH values. To run a trial test, I have here a liquid solution with a listed pH of 5.0. According to this coloration chart, the pH listed should show this as a very basic yellow-orange color, with some leeway due to my transportation of this liquid from my house to my dorm room having an effect on the hydrogen ions. Testing this on the pH test strip paper, we can confirm that the solution is indeed close to an acidic 5.0. Adding a drop of our indicator solution shows the liquid to in fact check out with the coloration, confirming the initial measurements. So now let's go ahead and move on to the tap water. So collected here is a recently dispensed glass of tap water, and we're going to go ahead and use both the strips and the solution to determine the pH. So adding several drops of water onto the test strip, we can see that the water displays as basic. This is further even backed up through the pH indicator solution color as well. Alright, so from both our indicator solution and our pH test strips, we have determined that the pH is approximately 8.5. Now, by subtracting that from 14, we are able to get the POH, which is 5.5, indicating that yes, this is a basic solution. We can easily get the hydroxide concentration by doing 10 to the negative POH. In the end, we can see that the hydroxide concentration of our tap water is 3.2 times 10 to the negative 6. So, what could be the cause of this? Well, upon researching College Station's water supply, the answer to this question becomes clear. The Bryan College Station area's water supply is practically entirely groundwater. And according to College Station's own government website, all is pumped from deep wells in the Carrizo-Wilcox Aquifer. Analyzing a 2019 drinking water report, we can find multiple culprits: sulfate, calcium, bicarbonate, and more secondary contaminants. It's important to know that these contaminants don't harm us, but they do in fact alter the taste of the drinking water and can have an increasing effect on pH, thus potentially even affecting our skin. And that, my friends, is the key to the puzzle.